In this video, let us learn how to calculate the calculated voltmeter reading for calibrating a low range voltmeter using a potentiometer. And we will also learn to draw the calibration graph. So, this is the reading observed from the experiment. We all know the experiment consists of two parts. One is finding the L naught and the other part is finding the L. The L naught is very important, and that is the balancing length. When the EMF of the Daniell cell is balanced, it is 550.1 into 10 power minus 2 meters. You have to note mostly the L naught will be around 500 plus. If you are getting less than that or more than that, you are going somewhere wrong in it. So keep it in mind, the value of L naught will be always around 500 plus, that is around 500 to 550. So here the L naught is 550.1 into 10 power minus 2 meters. Then we have the voltmeter reading 0.1, 0.2, 0.2, 0.3, 0.4 to 1.2. For want of space, I have taken only 1.2, but you have to take the readings till 1.5. So if you have more number of the readings, then graph will be very neat and you can draw the graph extensively. So for the voltmeter reading of 0.1, the balancing length is 48.1, and for 0.2 it is 102.7, and for 1.2 it is 607.3. See, you can also verify your readings. At 1 volt, your balancing length would have reached 500 plus. This is how you have to check whether you are taking the readings in correct sense or not. Okay, so keep it in mind, around 1 volt your balancing length will be closer to your L naught. So see here, it is around 515.6, so it is more or less correct. Okay, so next we have to find out what is our V dash, that is the calculated or corrected voltmeter reading. The formula goes like this: 1.08 L divided by L naught times volt. So let us do the calculation. So to find V naught, we have the values. For the first value, L is 48.1 into 10 power minus 2. L naught is 550.1 into 10 power minus 2 meters. We have the formula for corrected voltmeter reading. V dash equal to 1.08 divided by L naught into L volt. Substituting all the values, 1.08 into 48.1 into 10 power minus 2 divided by 550.1 into 10 power minus 2. The 10 power minus 2 in the numerator and the denominator gets cancelled. When you calculate, you will get V dash equal to 0.0944 volt. For a observed voltmeter reading of 0.1, we have got the corrected voltmeter reading as 0.0944 volt. So the correction goes like this: V dash minus V volt. So V dash is 0.0944 and V is minus 0.1. So the correction is minus 0.0056 volt. If you get a negative answer, do not bother about it. You may get a positive correction or a negative correction. In the same way, calculate V dash for all the V values. So if you calculate, you will get for 0.2 it is 0.2016, 0.3 0.3089, and it's 1.2 it is 1.1921. So you can check your answers by comparing V and V prime. So your V that is your V dash answer will be almost close to your V value. See, for example, for 0.6, look at 0.6, the observed value of 0.6, the obtained corrected value is 0.6054. And also see to that, when you find V dash, you have to take at least or minimum of 3 decimal points. Here I have taken 4 numbers after the decimal point. You have to take minimum of 3. So then then only we will be able to draw the graph. So next the correction is v dash minus v. We have for the first reading it is minus 0.0056, second reading it is 0.0016, for third reading it is 0.0089, fourth reading minus 0.0107. Do not bother if you get all the corrections in positive value or in a negative value, or sometimes you may get the combination of both positive and negative. For voltmeter to voltmeter the corrections may vary, or for the same voltmeter if, if you repeat the experiment you may get the different values, different correction values. So do not compare your answers with your friend and think he is getting in positive correction, we are getting a negative correction. So both of all of them are correct. You may get the correction in a positive value or in a negative value, or a combination of both positive and negative. So we have got the correction. The very important part of this experiment is drawing the calibration graph. In examination also the maximum mark will be given for plotting the graph only. See, now let us draw the graph. Take a graph sheet like this, and since we have negative values, if you have only the positive value, it is enough if we draw the graph in the first quadrant. If you have all the corrections in the negative values, you can draw it in the fourth quadrant. But here we have the correction values both in positive and the negative values, the combination of one positive and negative values. So I am concentrating, or I am taking both the first quadrant and the fourth quadrant. See, I have drawn x-axis and y-axis. I mean split the graph into x-axis and y-axis, and we have to take the observed voltmeter reading V along the x-axis and the correction V dash minus V holds in the y-axis. Then we have to take the appropriate scale values or appropriate scale for plotting the graph. For this set of readings, on the x-axis the observed reading 1 centimeter is taken, 1 centimeter is equal to 0.1 volt, 0.1, 0.2, 0.3, 0.5 we have to take, and on the y-axis looking at the values I have taken the scale along the y-axis as 0.002 volt, 0.002 volt. So depending upon your correction values you have to choose the scale. See, after marking the scale, see on the x-axis I have taken 0.1, 0.2, 0.3, 0.4, 0.5 in steps of 0.1, and on the y-axis, see along the positive y-axis it is 0.002, 0.004, 0.006 till 0.026. Onto the negative axis of y I have minus 0.002, minus 0.004 till minus 0.020. So this is the readings for which we are going to plot. This is V, this is V, and the correction V prime minus V. So we have the combination of both positive and negative values. With this value, plot the graph. See, for the point 1 it is minus 0.0056, which I have plotted it in the negative axis, and for point 2 it is 0.0016, it is in the positive y-axis. Then for point 3 it is also in the positive y-axis, and for the point 4 it is in the negative y-axis, so it is in the negative y-axis here. In the same way, plot excuse me, all the points till 1.2. After marking all these points, then join the points using a scale from 0 continuously till 1.2. So you will get a graph like this, like an up and down a graph. You will obtain a graph like this. So you have to plot the points corrected to a third decimal. So the graph plotted is both in the points in the y-axis, positive y-axis, as well as in the negative y-axis.